This is Untitled Atari 8-bit podcast.
Hi, I'm Kevin Savitz, and you are listening to a special interview edition of Antic, the Atari 8-bit podcast. Today's interview is with Bill Wilkinson. Bill was co-founder of Optimized System Software, the creator of Basic A+, Basic XL, Basic XE, DOS XL, Max 65, Action, and other tools, programs, and languages for the Atari 8-bit line. Bill personally coded Atari DOS 2 and Atari DOS 3, and he was the columnist for Compute Magazine. He wrote the Insight Atari column. This interview was conducted on September 25th, 2014, over the phone, while he was getting kidney dialysis done at the hospital. Sometimes you can hear in the background nurses talking about this and that, and we had to pause several times during the interview for him to discuss things with nurses. Bill is 70 years old and lives in the Seattle, Washington area. A couple parts of the interview get rather technical. I think it's amazing how much specific technical information Bill remembers after this much time. So here we go, Bill Wilkinson.
I put up on one of the Atari forums that I was going to be interviewing you, and I asked people, if they had any particular questions they want to ask, and there was a lot of interest. People love you and love OSS, and are still the Atari people are still super interested. So, do you want to start by telling me about how OSS got started?
Well, truthfully, almost by accident. No, that's not really true. It was my fault. There were four of us that were working for a guy by the name of Bob Shepardson, and his company was called Shepardson Microsystems. And he had decided to go out of business, and he owned while we were working for him, we had done BASIC for Atari, the assembler editor cartridge for Atari, and let's see, what else was there? Oh, and the math package for Atari. Atari themselves had done the operating system. And I guess we had a hand in the DOS operating system too, although we weren't really happy with the specs on it. And it certainly didn't turn out the way we had hoped it would, but never mind, we won't go into that. That was Atari's contract, not our choice.
Mm-hmm.
Anyway, so we had done all that, and we had also done Apple's Apple DOS, the original Apple DOS. And so we basically told Bob Shepardson that we'd take all those products and productize them and make, better versions of them, newer versions, updates, whatever, offer them for sale, and pay him a royalty on them, on what our sales were.
Mm-hmm.
And so we formed another company called Optimized System Software, starting with the four of us. It wasn't too long after that Paul and Kathy dropped out. Paul had gotten a full-time job, but he just didn't have time to participate, and Kathy was pregnant, so they just decided to drop out. So it was basically Mike and myself, and then we got a couple of more people hired in helping us, although it was just, to be fair, Paul and Kathy were there long enough to produce the first couple of products, which were Basic A+ and OS A+.
Mm-hmm.
What more can I say? That's just how it got started. We started with
a
slightly improved version of Atari Basic. It had the player missile move commands on it, for example. And I don't even remember all the commands right now. Basic XL and Atari Basic and Basic A+ were close enough that the differences, I won't say were necessary. Well, yeah, the differences were minor, quite honestly. They were. The big difference was that Basic A+ was strictly a disk. That we never produced a cartridge version of it, and then Basic XL was a cartridge version.
Oh, okay.
And
Right.
yeah, so I was the one that suggested the whole thing. So it came down on my head to keep it going. And I guess the big breakthrough was probably being able to produce the 16K byte cartridge.
Mm-hmm.
Because Atari had always planned for a 16K byte cartridge, but if you did that, you used up all of the memory space essentially. You know, you used up so much memory, and so our cartridge, you know, the trick to our cartridge was that it was bank selected, so that it only occupied 8K bytes of space, and
right.
the bottom 4K was always there, and then the top 4K was bank, you know, selected 1 of 3. It could have been 1 of 4, but that would have been an inconvenience EEPROM size. And
So
is that
something that had been done before, bank switching, or as far as you know, was that the first time that had been done, or?
Well, the first time, I don't know if it was the first time it was done that way or not. I never had seen it done. Believe it or not, the hardware circuitry was mine. It's the one and only hardware circuit I've ever designed in my life. But I got the idea because I had earlier worked for a company called Unicom, which later got bought out by Rockwell Systems, and we built a programmable calculator based on a 4-bit CPU, which was the Rockwell PPS-4.
Mm-hmm.
And that was a really fast machine. It was PMOS technology instead of NMOS technology, which really goes way back. And PMOS technology is much slower than even NMOS was way back then. And just as a for example, I wrote a sign routine on that using that chip, and it took 100 milliseconds to do a sign.
Okay.
Maybe, and sometimes closer to 200, depending what you were doing.
Mm-hmm.
So, slow to say the least. Anyway, right. that programmable calculator that we built, the Rockwell chip was only capable of addressing. I got to get this straight. Yeah, it actually had separate RAM and ROM address spaces. And the program had to reside entirely in ROM. You could not execute code out of RAM.
Mm-hmm.
And the ROM address space was 16K bytes, which everybody thought would. No, I'm sorry, I'm wrong. It was 4K bytes. That's right. It was 4K bytes, and we needed a lot more than that to do the calculator. So we actually had it organized as. Let's see, we had 2 1K byte segments that were there all the time, and then 2 1K byte segments that were swapped out where you could get 1 of 4.
Mm-hmm.
And so that was the first time I saw that done, and I learned the technique from an engineer there at Unicom/Rockwell.
So you ended up eventually using some different banking schemes over the years, right?
Yeah, well, we just, in order to use cheaper EEPROMs. Remember, the very first one was done with 2 8K byte EEPROMs. And when the 16K byte EEPROMs were available, we had to use a different scheme because you had to address the entire EEPROM rather than being able to address half an EEPROM.
Okay.
Or, you know what I'm trying to say. It wasn't a significant change, but it was just the difference between the 8K and the 16K byte EEPROMs.
Mm-hmm. Okay. So you said before something intriguing. You said you were unhappy with the DOS, the original Atari DOS, and you said you wouldn't get into that, but I totally want to get into that.
Oh, okay, we'll get into it. The Atari DOS was quite honestly idiotic. The whole idea of wasting 3 bytes in each 128 to provide a link to the next sector.
Mm-hmm.
That's crazy. I mean, it's so much easier to just use a table of sectors that you load in.
So was that linking thing an insistence? Atari insisted on that?
Well, Atari wrote the spec on it. We just wrote the spec. Okay.
Mm-hmm.
That was well, when we came out with what we called sorry, DOS X. Let's see, what was which version was that? That was, I guess that was originally ADOS 4.0, and that was actually a port. That was actually a port of Apple DOS to the Atari, and it provided for. Well, okay. The other thing that was wrong with the Atari DOS was that in order to readdress someplace on the disk, you had to find it first, which basically meant reading to it. You know, reading forward all the way to get to wherever that spot was, remembering it by way of the pointers. You know, you got a basically a 24-bit pointer that pointed to you to where you were on the disk.
Mm-hmm.
And then later using those same numbers to do the put, you know, to point, in other words, to that spot, right?
Right.
So you'd have to get the pointer first, save it someplace, and then use it again later. Well, again, that's silly. I mean, okay. One of the things I did on the side while we were waiting to try and get some money was I actually wrote a general ledger system and an accounts receivable and accounts payable for a friend of mine who had written them for the Apple and had written them for the IBM the PC Junior. And when I rewrote them using Atari DOS and Atari Basic, I had to basically what I had to do was I had to go and first write the entire disk worth of records for the general ledger, let's say.
Mm-hmm.
So I fill up the disk with records for the general ledger, and as I'm doing that, I'm recording the beginning of each record into a separate table, then I then write into a separate file. And so then the first thing I do when I boot up the general ledger is I read in this file that has all the pointers to where the records are, and now I can use the records at random.
Mm-hmm.
In other words, I created my own random positioning, if you will.
Okay.
And so those are the two things that were wrong with Atari DOS. You know, just the lack of being able to address a location just by logical location instead of physical location. And then the fact that they wasted the 3 bytes in each sector.
One of the questions that a user sent me, he said, like DOS seemed very flexible in that you could change the number of drives and buffers in order to optimize memory usage, but the format itself didn't provide much flexibility for future expansion, like
right.
More bytes per sector or sectors size, that sort of thing.
Exactly right. And you know that's what we tried to do with our DOS 4, and it was never very popular, so we never went anywhere with it. That's what other companies came in, especially my mind's gone. The guys in Michigan that we ended up selling the stuff to. Come on, help!
I'm trying.
The guys that sold drives and sold controllers and all.
ICD.
ICD. Thank you. I was trying to say IED, and I knew that was wrong. So anyway, you know, they came out with theirs, and a couple of other people came out with replacement DOSes, and so we just never.
Said,
go ahead.
I'm sorry. Go ahead.
I just said we just gave up on ours.
So you said your DOS. I don't know which one you just said. Your replacement DOS was not.
Yeah, the thing that I don't think we sold more than a handful of them, probably a couple of hundred, maybe as many as 500, but I doubt it. It was originally OSA plus 4, and then I forget what we renamed it when I guess, yeah, that's what it was. It was called OS/A+4. That's exactly what it was called. Right. Never mind.
Okay.
We never changed the name on. We did not change the name on that one. The original name for OS/A+ was CP/A, and we introduced it at the West Coast Computer Fair, CP/A, and immediately a lawyer from Digital Research comes over to us and says, "You're going to have to change that name." And I don't think we really had to, but we didn't want to hire a lawyer and fight them, so we gave up.
Right.
We changed it.
Right. So why do you think OSA Plus was not a big seller? My intuition is that most users who aren't super power users are going, I already have a DOS, it's good enough. It may not be perfect, but it's fine and it's free.
Oh, well, we did change OSA Plus to handle the next size up disk drives, which Atari didn't get around to doing until late in their life.
Mm-hmm.
It just wasn't, I don't know, I think it wasn't a big seller because in order to run most things on the Atari machines, you needed to run Atari DOS or something that was an exact replacement. And why use an exact replacement when Atari DOS is free?
Right.
Sure. And it was just a matter of economics, I think, for most people.
Yeah.
By the way, we should point out that the flexibility for adding disk drives, D1, D2, D3, D4, etc.
Mm-hmm.
That's all built into the ROM on the Atari. That's not a part of the DOS per se. That's a part of the internal operating system.
Did you guys have any involvement in DOS 3?
You mean Atari's DOS 3?
Atari's DOS 3, yeah.
Yeah, I wrote it.
Okay.
Yeah, I wrote that way back at towards the end of OSS. Just as Atari claimed that they were going to push that into South America and places like that,
Mm-hmm.
and of course it never went very far.
Right.
But I tried to do it right. It was theoretically capable of handling any size disk drive. Well, anything up to 16 megabytes, I should say. Atari never. It just needed little plug-in drivers to do that.
Mm-hmm.
But Atari never asked me for any drivers beyond the original ones, and obviously there was no point in my producing any if they weren't selling any. So.
Right. So they just contracted you to create this thing, and then they sort of ignored it?
Well, I think it was a last desperate attempt to do something with the 8-bit line,
Mm-hmm.
And they thought maybe they could sell it into. They told me South America,
Mm-hmm.
places like that. They were ramping up a South American division supposedly, and that's why they had me do it. But obviously, it never went anywhere. So who cares?
Right. Right.
I had nothing to do with the original DOS, by the way. That was all done by Paul and Kathy.
Okay, you said OS A+4 wasn't working out, and then you guys switched to DOS XL.
Yeah, and then we basically dropped OSA. Then we basically dropped OSA Plus version 4.
So OS A Plus version 4 was not doing well. You said it was not selling. So you switched over to DOS XL. Why?
No.
Why did you switch?
We had OS. No. Sorry, you missed. I'm sorry. We missed something in there. We had OSA Plus version 2 and version 4, and they were completely different. 2 was compatible with Atari DOS. In other words, it was for Atari computer drives, ones produced by Atari.
Mm-hmm.
It was compatible with Atari DOS.
Okay.
But version 4 was not compatible. The disk format and everything else was completely incompatible. It was actually compatible, as I said, with an Apple DOS. I guess it was Apple DOS 3.3 was the official version. Was actually compatible with, excepting of course that the disks, the Atari disks didn't have as much capacity as the Apple disks did. So,
mm-hmm.
so it wasn't really compatible anyway.
That's crazy, though, that on a logical level, at least, they were compatible. It's just nutty.
They were. Yeah. Yeah. Well, that's because that's another case of a company that screwed things up completely, okay? Apple never, ever produced a larger disk drive for the Apple II computer than the original one.
Right.
Okay? Even as popular as it was. And yet, Apple DOS 3.3 was perfectly capable of handling disk drives up to 16 megabytes. And all you had to do, I said install a plugin. It wasn't even really that. All you had to do was to add some table entries to a drive table that described what the drive sizes were.
Seems like it would have been easy enough to do.
It was
right.
trivial to do.
Right.
Trivial to do. And yet, Apple never did anything with it.
So on one hand, you had Atari, who was trying to release bigger drives, double density and things, but couldn't get it together well enough to make a decent DOS to support it. And then on the other hand, you had Apple, which had a DOS that could support it, and yet didn't get it together to make the hardware.
Exactly. So in both cases, you had third parties coming in writing new DOSes so that they could use bigger drives.
Okay, I feel like I'm ready to move on to talk about basics, but is there anything else about DOS that we should?
No. I think that's more than enough. I think we've exhausted it to the point of anybody would care.
You don't know my listenership, sir. These are Atari geeks that will some of them hang on every word.
They can ask more questions later.
Yeah, they will complain to me. But you didn't ask about this particular fine point of info. I'm sorry, sir. Right, doing my best. All right, let's talk about basics. So you guys did Atari. Well, no, sorry. Paul and Kathy did Atari Basic, right?
Right.
And then you guys swept in to decide to do things better and faster. And tell me about that.
Well, we just knew that there were a lot of limitations that in the basics. And first of all, by going to the Basic A+, which was on disk, we weren't limited to an 8K cartridge. And same thing was true then when we went to the 16GB cartridge in Basic XL. And we just, with Basic A+, we added in the things that we knew were missing. Like speeding up the go-tos and the go subs, and then in Basic A+, we added in features like the missile moves and player moves and all that kind of stuff. Let's see, what else did we add? I don't remember exactly when we added everything, but let's see, we added with Basic XL, we added being able to list your variables and get references, things like that,
Mm-hmm. Question from the Peanut Gallery was, why did you have regular integer variables why didn't you have regular integer variables instead of using floating point for everything? And it's not even something that got corrected in Basic XL.
That's something we should have corrected. I think you're right. I'm not sure it would have made a huge amount of difference, except it probably wouldn't have made much difference except when you did things like multiply and divide. The conversion routines for converting the floating point numbers to integers for doing the go subs and go tos and that kind of stuff were pretty efficient. And you only had to do them one time for a go to or a go sub. So in any case, they were we could convert a floating point number to an integer in range, which had to be 32. Had to be only 16 bits, really fast because you knew immediately if the number was out of range. Floating point number was out of range. Truthfully, the reason it was done in the first place was at the time we wrote that Basic, it wasn't traditional to have variable types. I don't think there was any other BASIC in the world at that time that had anything other than floating point and strings.
Mm-hmm.
The exception, of course, being Apple Integer BASIC, that it didn't have floating point.
Right.
So variable types per se, other than numbers and strings, just weren't traditional in BASIC.
Mm-hmm.
We wrote a BASIC for Memento, which is a super high performance BASIC, and it never had integers. It wiped up the competition with any other BASIC that was out there.
Yeah.
And even Atari BASIC, even Atari BASIC X, Atari BASIC XE, it wiped it out, and yet it didn't have integers. So it was just not traditional in those days.
Right.
But it was something we could have added later. Yeah. It would have changed the structure of the language compiler somewhat. And then you also have the problem of as soon as you introduce integer variables, now you have to handle mixed mode arithmetic.
Right.
Yeah. What do you do if you divide an integer by an integer? Do you do integer division, or you do floating point division and then reduce it to an integer?
Mm-hmm.
Don't know. It's an interesting question. But the truth of the matter is, it really just goes back to the fact it wasn't traditional.
It's not how it was done, right? Right. So did you guys also do a BASIC for the Atari 7800 game system that was never published?
I did, yes. That was another one that I did all by my lonesome.
Tell me.
And it was more like BASIC XL than it was like Atari BASIC.
I'm sorry, can you say that again?
I said it was more like BASIC XL than it was like Atari BASIC, in that it had players and mover, objects that could be moved. Yeah, I don't even remember all the details of it. It was fascinating because I wrote it. I wrote most of it. Okay. I wrote most of it back home, and then brought it back there to Boston and debugged it back there, and then I'd go back to California, write some more, and come back to Boston and debug it. And I managed to do it in only 3 trips.
Wow.
Had it up and working.
Why did you do it in that way? I mean, in 2 different cities.
Oh, because they didn't have a real machine for me to work on. They had a ROM emulator machine. So I would load my code into the ROM emulator, and then we used the ROM emulator with the 7800 mock-up.
Mm-hmm.
So they didn't have any spare machines to give me.
Did you do other projects for the 7800?
Nope, that was the only thing I ever did. It was a really weird machine. The graphics, I mean.
Yeah.
Yeah. Display list. Gosh, I remember those. Let's see. 40 bytes per display list entry. So if you wanted an 80-character line on the screen, you had to put 2 display lists at the same vertical position, but at but the one at the offset horizontal position.
Oh. Yeah, that's kind of strange.
Very strange, yeah. And the players they didn't have missiles per se, but the players were even stranger. I don't remember the details of them, but they were strange. Fun stuff. It was an interesting project.
Did you do other projects for Atari that never saw the light of day?
Let me think. No, I don't think so. Nope.
Did you do other projects for OSS that never saw the light of day? Ideas that you had that never came to fruition, for instance?
We started a few things, but we never got to the point of finishing them.
Such as?
Oh, let's see. Well, we started a word processor of our own, for example, but then we ended up buying that one that we did, and it was enough better than the one we had that it made a lot more sense to buy it.
So the one that you released was called the Writer's Tool.
The Writer's Tool, right? It was actually, considering the state of the things at the time, it was pretty reasonable. I used it myself to write things sometimes.
Mm-hmm.
Heck, I think I wrote some of my Insight Atari articles on it, in fact.
Cool.
Which, of course, I didn't need to because they got retypeset anyway. So most of the time,
right.
I would just write them with a text editor. But hey, what the heck?
So were there any other projects that OS has started and abandoned?
No, I think most of the projects we actually did came to actually ended up being produced because, quite frankly, we couldn't afford to start on do projects and not outsell them.
Right. Sure.
I mean, there might have been some other things we had ideas for, but they weren't things that got beyond that stage.
Mm-hmm. So the Writer's Tool seems like it's just an interesting project for you guys because it's sort of out of your normal realm of what you guys made. I mean, there's a lot of programming,
Yeah, well, like I said, we started to do one of our own, and this guy then approached us, and we looked at it, and we said, why finish ours? Let's just do his.
Mm-hmm.
So,
cool.
The fact of the matter is, by the time we had completed things like Basic Excel and Math 65, and we were already starting Basic XE, and I guess the one thing we did with DOS XL, I don't know if you remember this, was that we created it in such a way that you could stick the code for DOS XL underneath Basic, underneath Basic XL. Turn off the cartridge completely so that you'd have the RAM there instead. That was one feature of DOS XL that people that programmed like to have. And so people that were programming in Basic XL as opposed to just running stuff in it would sometimes buy DOS XL because that gave them an extra 8 bytes of memory.
I didn't know that. That's cool.
Yeah, and that was even in a 48K machine, right?
Right.
Of course, then later, when Basic XE came out, we bank selected the RAM and the 130 XE. That's why it was called Basic XE, because it would bank select the RAM and the 130 XE and use it for additional programming space. Did you know that?
I did not know that.
Aha. Yeah. That's the 130 XE had 128K bytes of memory, and the top 16K bytes of the 48K was bank selectable, so you could select any one of 4 banks.
Okay.
And then there was a trick where you could actually turn off the ROM operating system, the top 16K bytes of memory.
Mm-hmm.
You could actually turn that off and use its RAM underneath it. So in theory, you could have just turned off all of the ROM on the Atari and run everything out of RAM, giving yourself 128K bytes of memory.
Huh.
But it would have been really, really complicated to do that.
Sure, because you can't use any OS calls or anything at that point.
Sorry. Well, no, you could. That was another feature of the Atari, was that they had, if you remember, that OS calls could go through a RAM vector. So you'd send them through a RAM vector, and the RAM vector would turn the ROM back on again and execute them.
Wow. Cool.
I think we actually did that with Basic XE. I think that's where we got the other 16K bytes. Yes, that's what we did. That's right. That was the other reason Basic XE would only run on the XE. Well, no, wait a minute. I don't think that's true. I think it could run on a non-XE, but then it had to eat up memory that you didn't want to eat up.
Huh.
Yeah, I think that's true. It's been too long. I never had a 130X. Never had a 130XE and Basic XE my own. Had one on the company. But never had one of my own. So.
What was your first Atari machine? I mean, it was an 800, I assume, or?
Oh yeah, sure.
Yeah.
Yeah, we all had 800s and 800 XLs. Or sorry, 800s and a pair of disk drives. And we thought we were living in heaven, of course. No, that's not true, because at the same time I had a Crememco machine in my house, which had it had 192 KB of memory. And that was bank selected memory too, by the way, because of course that was running with a Z80 processor, and so it also could only address 64 KB at a time. But that was running 192 KB, and it was running what did they call it? Chromix, which was a Unix clone on an 8-bit machine. We used that to develop a C++ for Crememco.
Let's talk about Action.
Yep. Great little programming language. Incredible little programming language.
Yes, I'm a fan. I'm not an expert in it by any means, but I am a fan of Action and have dabbled with it. And so yeah, tell me about it. I mean, what was the inspiration for, hey, let's create a new language?
Oh, no, it wasn't our inspiration. That was Clinton completely. Mm-hmm. He came to us and said, hey, I want to do it. We said, okay. Because he wanted to do it in a cartridge, because it works much better that way, because it gave you more memory. Mm-hmm. And you could stick DOS XL underneath the cartridge again, give yourself more memory, right? Mm-hmm. And we worked with them to work out how to do the banks, what code to put in what banks, etc., that kind of stuff, and basically he wrote it all by his little lonesome. And it's truly a fabulous. It's the most efficient compiler for a 16-bit machine, an 8-bit machine, that I've ever seen. It generated wonderful code. The compiler itself, of course, was really small. Mm-hmm. The library was more than adequate for most things, and you could add disk libraries to do the stuff it couldn't do. Don't know what else to say. It's about as close to a C lookalike as you could be on that machine.
Did you end up? Did OSS use it internally after it existed, or did you just continue to do everything in
an assembly language? Oh yeah, we still had to do things. It was never going to be as efficient as assembly language. I mean, I would guess that it would probably, at its best, it would produce code that was maybe 3 times less efficient than assembly language, mm-hmm. and at its worst, maybe 10 or 15 times. Mm-hmm. Although that's pretty uncommon. Only a few structures work with it like that.
Was Action a commercial success?
Oh, yes, definitely. Yeah. I mean, not as much as Basic XL, but I would say probably second behind Basic XL.
So what did that mean back then? I mean, what did it mean to be a commercial success? I really honestly no idea. Are we talking 10,000 units? Is that?
Yeah, I would guess Action probably did between 8,000 and 10,000 units, something like that. Yeah. When we came out with Pascal for the ST, when we produced the new version of it, the second major version, not including just revisions, but the really a complete second version, new libraries, the whole schmear.
We're talking about Personal Pascal for the ST, right?
Yeah, Personal Pascal for the ST, yes. We also had Prologue for the Mac, so I had to make sure I was on the right machine. Anyway, Pascal, the second version of Personal Pascal, which was, expanded. The manual was twice as thick, et cetera, et cetera. I mean, it was a pretty massive upgrade. And when we took pre-orders for the upgrade, because we wanted to make sure that we had a product that was worth doing the upgrade, right?
Mm-hmm.
When we took pre-orders for it, we had like 7,000 pre-orders, and eventually we ended up selling like 12,000 copies of it. So we were enormously happy with that.
For the Pascal program.
Yeah.
Yeah.
But that was honestly our last success, and after that everything started going downhill.
Right. So you did all those products for the Atari 8-bit, and you did the Pascal for the ST, and you did Prologue for the Mac. You said. Right.
And Prologue was actually done by Paul, the guy that helped found OSS. And he came to us and had us sell it.
So why didn't OSS expand and diversify to other platforms? For instance.
That's wrong question. Okay.
Okay.
The right question is, why did we ever do the Atari platform in the first place?
Okay.
And because, quite honestly, we didn't realize how few sales Atari actually had. Atari exaggerated their sales, even to their own staff. Okay. And we just didn't have the money. I mean, when I say things were a success, that means it was at least break even.
Right.
By the time the 8-bit machines were dying completely, we were dead too. So we weren't making any money anymore.
Okay, then that gives me to the follow-up question. I mean, you were in the game with Atari long enough that eventually you had to have realized, okay, they've inflated the sales numbers and the market's not as big as they claimed, and yet you stayed with it from the initial line through the XLs to the XB years.
Because to start a whole new product line,
mm-hmm.
and break into the PC market at that time would have cost us a lot more money than any of us had.
Sure.
Okay. I mean, I personally lost, oh golly, I don't know. Probably, if you talk about lost salary, I probably lost $120,000 to $150,000
mm-hmm.
in the course of the time I was with OSS. Okay.
Just by not taking a paycheck, that sort of thing.
Right, not taking a paycheck, not making a decent money at some other company.
mm-hmm.
And I actually physically lost. I guess let's see. Probably $30,000 or $40,000. There was money that we took out on our house. Refinanced our house and used to live on,
mm-hmm.
and never got back. So, looking back on it, it was a dumb thing to go into business.
Yeah.
None of us had the right smarts to be business people. We were technical people, not business people. Oh, all right. Where weren't we? Oh yes, we're at the end of the depressing news. We're not going to go into that anymore. No, I don't mind the fact that it was. We needed a business person to help us run, and we just never had one. We couldn't afford one.
Mm-hmm. Okay.
I mean, we all went on to tech jobs and interesting jobs and advanced software and all that kind of stuff. So it wasn't because we weren't capable of it. It was just of the technology. We just weren't capable of doing the right business decisions.
At any point, did you guys say to each other, wow, we should have done Commodore 64 stuff because there's such a larger user base there? Or
On the what 64 stuff? Say again?
the Commodore 64. I mean, they sold millions of more machines than the Atari.
Well, we didn't even know that at the time. By the time we knew that, it was too late, honestly.
Yeah.
The Commodore market was pretty well flooded by that time. There's a couple of products I wish we had come out with for the Commodore. We should have done Action for the Commodore, and we probably should have done a basic XE equivalent for the Commodore, or at least a basic XL. Certainly their basic wasn't very good, or very fast.
Right.
They were using Microsoft Basic, and let's face it, Microsoft Basic was crammed into a machine that size is just nearly impossible.
Okay, let's see. Let's go back before we get to the end of the company. We haven't talked about EASMD, your assembler editor.
Right. That was almost a clone of the Atari assembler editor. Not quite, but pretty close. And I can't remember what changes were in there that weren't in the Atari one. The big thing was EASMD was on disk, not in a cartridge, right? So that allowed us to keep the cost down, but it wasn't particularly popular. And there were just some very minor things that were changed, some bugs fixed and things like that. No, I take that back. It wasn't bugs fixed. That's a story in itself. I need to tell you that story. So
I'm ready.
For the Atari, first of all, you should hear the Atari story about Atari Basic if you've ever heard that. We started the contract with that. I think it was in September, and Atari was going to I can't remember to Consumer Electronics Show in Las Vegas in January. And they wanted to have something they could take with them. And so Paul and Kathy got the butts in gear and wrote that thing, and they had that thing up and running by December 1st. Or maybe, I take it back. It was December 15th or so, something like that, because they went on Christmas vacation. And Atari put that thing into EEPROMs, took it to the show, came back and put it into ROM immediately.
Mm-hmm.
Never giving us a chance to debug it and fix the bugs. And so I don't know if you remember, but there's the infamous editing bug. You could be editing a program and your whole machine would lock up.
Mm-hmm. Yeah.
And that was just because of a one-line change that needed to be made in the routine that shifted code around when you edited it. That was when you would delete a line and then reinsert it.
Mm-hmm.
I don't know how familiar you are with the internals of it, but basically when you typed in a new line, we didn't really give you a way to edit it per se. That you had to essentially you could list the line and get that line and then edit it on the screen. But then when you hit the enter key, what actually happened was that it first of all compiled the line into the bytecode, and then it removed that line entirely from the program space and then reinserted it entirely.
Okay.
And the bug was that if the I can't remember now. It's either the line being removed or the line being inserted. I think it's I don't remember which one it is. I think it's the line being inserted. No, it's the line being removed. I do remember that. I remember that now. Boy, wow, you're really stretching my memory. Anyway, if the number of bytes of program space being used above the point where the removal took place was an even multiple of 256 bytes, then the machine would lock up because it goes into an infinite loop. Isn't that fun?
Yeah, that's
Talk about obscure, right?
yeah. Well, yeah. Until it affects you because your program just crashed.
Yeah, exactly.
Yeah. So, do you have any idea why Atari went live with that unfinished BASIC and burned that to ROM rather than waiting for you to fix it?
Well, in fact, they never even did any what I would consider beta testing. That was how Atari ran in those days. Wow. They were slightly crazy. They brought other products out to market, remember, that had bugs in them. So a lot of games had bugs in them.
Yeah.
Not so fatal in a game. Well, I guess it is just as fatal if you're playing the game, but what I mean is at least you don't have to type the program in again.
Right.
So, anyway, where were we? Oh, we were talking about the assembler editor cartridge from Atari.
Right.
So, after that, Atari contracted with us to do that cartridge, and Kathy did that all by her lonesome, excepting. No, she did. I don't know. There's no exceptions on that. Kathy did that all by her lonesome.
Mm-hmm.
Well, many years later, Atari came to when they finally, they burned ROMs on that one also without testing it, right? So many years later, when they finally ran out of ROMs, and they decided they're going to burn a new set of ROMs, they came to me and asked me to fix it.
Mm-hmm.
Okay, and they had a whole list of things to fix, excepting that not one of them was actually a fix, excepting for one. There was one and only one bug in that cartridge that Kathy did all by herself.
Wow.
And you ready for this? In 1 month.
It's incredible.
Incredible. Yeah. I've never seen somebody code that well and so fast and everything. I mean, I thought it was pretty incredible the BASIC cartridge came out as well as it did, but at least we did some testing on that before it was released.
Right.
Anyway, the bug, for what it's worth, the reason for the bug,
mm-hmm.
There's a table in there of jump addresses. And the way you implement a jump address on a 6502 is you push the address onto the stack and then do a return. Okay? But the address you push on the stack has to be one less than the address you want to jump to. Okay? So you have a table, for example, of, for example, in the debug, and this was in the debugger, by the way. In the debugger, there's a table of what to execute when a certain instruction is encountered.
Mm-hmm.
So if the ADC instruction is encountered, you do this. If the JMP instruction is encountered, you do this. And if the INX and INY instructions are encountered, you do this. So you jump to certain addresses, right? And so the table simply consists of a whole string of, I think they were called .word, address -1, .word, address -1, .word, address -1. Okay?
Mm-hmm.
Where the address is the address of the routine to jump to. One of those had a semicolon instead of a minus sign. The one was there. Oh, and there was a semicolon after it, too, to say this is INY, the increment Y instruction.
Mm-hmm.
But the minus sign was converted to a semicolon. Here's the best part about it. That wasn't even Kathy's fault. The way we coded in those days was we actually wrote our programs by hand, and then we had a guy, Mike actually, the one who co-founded OSS, actually key punched them onto punch cards. And then we ran them through an assembler on a 16-bit machine that Shepardson had. And convert that spit out a paper tape, and then we would convert the paper tape to an EEPROM. How was that for fun? Or we actually had a paper tape reader that we could hook up to the Atari and read paper date from there. No, sorry, not the Atari, to the Apple. Anyway, so Michael had miskeypunched Kathy's minus sign as a semicolon. Oh, and semicolon. And the reason we didn't get an error from the assembler is because semicolon simply means begin the comment here.
Right.
So everything from the semicolon on is a comment. And so that was the one and only error in that cartridge. Now, don't get me wrong, there were lots of things she could have done better and more efficiently.
Mm-hmm.
And maybe she would have if she'd had more time,
Right.
And so the new version of the assembler editor cartridge that I gave to Atari had a lot of the things in it that the Mac 65 cartridge had in terms of being able to speed things up. But of course, it couldn't really have any extra features because it just wasn't within the cartridge.
Right.
I had to. One of the ways I would go and try to find efficiencies was I'd go, try to find places to speed up code, and often trying to speed up the code would take more code. So what I would also have to do is then go look for places in the code which weren't as efficient as they could be and recode them so they'd be more efficient, just to give myself more space. So it wasn't a trivial task. I mean, I probably spent 2 months fixing the cartridge that she wrote in a month. Well, I was doing other things at the time. I mean, I was helping run the company and everything else at the time. So,
right.
But even so, it's a fun story. I love it. Oh, and Kathy, by the way, is now a professor at Cal State San Jose.
Yeah, I've talked to her husband. I interviewed him, and then I need to circle back and I think talk to her too, because she sounds fascinating. So the end of OSS, what was the final straw? I mean, you said you weren't selling a lot of product. You were losing money. At what point did you throw in the hat?
Oh, quite frankly, we threw in the hat when ICD offered to buy the assets.
Mm-hmm.
Yeah, but we were already down to the point where we didn't even have we weren't renting office space. Our office space was in Mike's house. So we were already down to that point. Mm-hmm. Mike and I were the only ones left.
Yeah.
No, I take it back. We had one more person with us then, just helping do shipping stuff. But it would have, I was out. Well, I actually already had another job by that time, so it was really Mike running things by himself and me just helping out when I could.
Yeah.
I think we sold it to ICD in February, and I had gotten a job in September or October. That's how I remember it.
Have you ever released the source code to anything?
Well, other than Atari Basics, Atari DOS, I guess not. And it wasn't on purpose. I mean, there was no reason to hang on to it. Well, no, there was a reason to hang on to it. I mean, when we sold the rights to ICD, they acquired all the rights to the source code. So we really didn't have a choice there. Could we have released the source code before then? Quite honestly, I don't think there was much call for it at that time. I mean, we still had the product, and the product was still available from a few dealers, and there was no reason for it, and we weren't trying to be stingy about it, but we just didn't even have the right.
Right. The Atari community is eager to get access to the source code if it even exists anymore. So that's why I ask.
Yeah, if it exists, ICD has it.
Yeah. Okay.
I don't think it would be that hard to regenerate it.
According to
because
go ahead.
I was thinking hard about that. How hard it would be to reconstruct. Okay. Mm-hmm. You've got the Atari Basic source code, and even basic XE, but let's not talk about it because it was never very popular. Let's go with basic XL, okay? Basic XL was pretty much built entirely on top of Atari Basic. And so, for example, the syntax tables that are used to convert source code into bytecode, they're still there. I mean, they're extended. They've got more entries, but they're still there. And those are the secret to the whole thing, quite honestly. Without those, it's really hard to figure out how that compiler to bytecode works. And I told you about the jump tables, so those aren't hard to figure out. If you see a whole bunch of 16-bit numbers in a row that look like addresses, they are. But they're just address -1. So just go, when you're looking for where they jump to, just go look for that number +1.
Right.
So I don't think it'd be an impossible task to take apart to rebuild the basic XL source code at least. Assembler editor, I don't know. I don't remember enough about that one to do it.
Yeah.
Off the top of my head. It probably wouldn't be too hard. Assemblers in general are much easier than compilers. So,
according to something I read online, and if it's on the internet, it must be true, right?
Right.
According to this particular thread, ICD never purchased ownership to the software they sold, but instead purchased license to sell it. So, but I guess it might have been different in your case because
that was only true with one product. Oh, sorry, that was true with two products. That was true with Mac 65, and that was true with Action.
Okay.
Because we did not own those products. Remember, we were only licensing them.
So I take it that means that you don't have any. You don't have any Atari stuff anymore. Yeah. I mean, do you have any Atari stuff at all? Do you kind of solve
I have one 8-bit machine and one disk drive, or I think it may be even 2 disk drives that may or may not work. I haven't tried them in 10 years, honestly.
Yeah.
It's just my interest is in writing software. And there's no reason for me to write software on an Atari 8-bit machine or even an Atari 16-bit machine. I do write software as a hobby, but I write it as a hobby for personal interests. And mostly what I write in the way of software then for personal interests is for the web, for HTML or things like that, I'm really into JavaScript, for example.
What kind of projects are you doing now in JavaScript?
Well, not a whole lot now because I'm semi-retired because of all this dialysis and stuff. And I'm only working 15 to 20 hours a week now on a contract basis. And mostly that's, quite honestly, code maintenance. A lot of it is code maintenance of ASP, which is a Microsoft technology for server-side development. I do some ASP.NET, and then I do a lot of, like I said, I don't really do much HTML per se, because I'm not a designer, and HTML really should be done by designers to produce pretty-looking pages, right?
Right.
But I do a lot of JavaScript to support them, and I do a lot of code behind the scenes to support the designers. So, and then I haven't really done much of anything for myself in a while, except just played around with some JavaScript puzzles.
So looping back to Atari from the JavaScript thing, I be interested to know that. So there's a project called JSMeth, JavaScript Multi Super System Emulator thing. Well, basically, the long and the short of it is they have completely emulated Atari 800 in JavaScript.
Oh my God! I knew it had been done. I knew it had been done in some other language. I think C or C++.
Right.
But
they took that and they tweaked it, and I mean they did a lot of work. So basically, yeah, you can run pretty much any Atari program in your web browser now.
Oh, God. All right. Now I'm going to have to go look that up. Oh, my gosh. I love it. I'm not surprised. I mean, JavaScript is enormously powerful. It's not the language I would have used to write a compiler, though. Well, wait a minute. They're not doing that. They're not emulating a compiler. What am I talking about? Shame on me. Ignore that. They're just emulating the hardware. Yeah.
Yeah.
Oh, I love it. I love it. Yeah, that really just means you have to emulate the screen, and you have to emulate the 6502 instruction set. That's about it, isn't it?
Right.
Yeah.
Yeah.
Yeah, because once you've got the ability to emulate the 6502 instruction set, then you can emulate the ROM space, with the OS in it.
The only problem they've had, which they are addressing, and it's still but it's like the hiccup they've had is sound, because pushing out real-time generated sound to the web browser is sometimes flaky. Sometimes it sounds bad. Sometimes it sounds great. So,
I can see that. It depends on what the Atari machine is doing at the time. I can understand why that would. I can see that. I really can. Yeah. Yeah.
Oh, let's talk about Insight Atari.
Oh yeah. Go ahead.
I read it religiously. I mean, to open the compute, that's what you turn to, Insight Atari.
Yeah.
Tell me, Tell me how you got the gig and what it was. How you chose the topics. Tell me everything.
I asked for it, quite frankly. I thought that compute's coverage of Atari was weak, and I thought, that there were some interesting things to cover. And I wrote one article for them, and Richard Bransfield, gosh, can't believe I remembered his name after all that time. I think I've got it right.
Yeah. Mansfield.
Mansfield, thank you.
Mansfield, yeah.
I was close, come on. I knew that sounded just a little strange. Anyway, he semi-rejected it. He called me up and said that this would make more sense as a column, because I had written about a few fragmented things, if you will, right?
Mm-hmm.
And so I said, okay, let me rewrite it as a column. And he said, okay, but I got to get at least one column ahead, so send me two. So I sent him 2 columns, and he said, okay, we're going. And that's how it got started.
Yeah.
And how did I choose topics? Shoot. Sorry, my wife was calling. I just declined her. She's going to be mad.
Oh, you're going to get me in trouble now.
Yeah. I'll have to call her back in a few minutes, so we'll have to break this up pretty soon. Anyway, besides which, my arm is starting to get tired. I can't hold it for much longer.
Okay.
Hold the phone again. It's just amazing. It's amazing what you do with 2 hands you can't do when you only have 1 hand.
Yeah.
Usually the topic was something that was, first of all, sometimes I would just pick a topic out of Blue Air just for the fun of it.
Mm-hmm.
But usually it was something that came from a reader's question. Richard would forward me the reader's question. And if there weren't any questions that sounded really good, then I would write something I wanted to write.
Awesome. That's the best way to do it. I mean, it was a long stretch. I mean, I'm looking at the thing here. You started in October 81 and you went through April 88.
That's right. And it dropped in because they dropped it. I would have gone on writing it for a little while longer. They dropped the Atari coverage, yeah.
Yeah, just PC stuff.
Right.
Yeah.
Yeah. I think my favorite column of all time, though, is still Atari COBOL.
Atari COBOL?
Yeah.
Was that the April Fool article?
Yeah, the April Fool article in April of 82. I'd always wanted to do an April Fool article because that was a tradition in, what magazine was that I used to read all the time? Always had a April Fool's article.
Oh, I don't know. Creative computing did it sometimes.
I think it was Creative Computing. I think you're right. It was either that or it might have been Byte back in the early days. Might have been.
Mm-hmm. April '84 is the COBOL joke.
Oh, is it? Oh, I was wrong.
Yeah.
Okay. Came later in my life then.
Right. The one I particularly remember is the one that I had all sorts of silly Atari news, but then if you took the first letter of every title.
Oh, right. I forgot about that. Yes. Yes.
That was April '85. So was that just like was it just like a freelance arrangement where they just paid you a flat fee per article and let you do what you wanted?
Yeah, pretty much. I mean, I don't think Richard ever rejected one. He would edit some of them, for length especially. Mm-hmm. But he never rejected one.
Cool.
So I guess I did okay by his life. Oh, wait a minute, I have to tell you a cool story that I think Atari people should know, okay?
Okay. Yeah.
Are you a science fiction fan?
Certainly.
Okay.
Yes,
Do you know Ender's Game?
Yes.
Okay, which of course came out as a movie this year, finally, after all
Right.
these years. Okay, Orson Scott Card, was an editor at Compute Magazine for a while.
Right.
Okay. He was my editor for the book that we were writing that never came out.
What book was that?
It was going to be a book on Teach Yourself Basic.
Okay.
It was going to come out for the Atari and for the Commodore and the Apple.
Okay.
But by the time we finally got the book to the stage where it was almost ready to print, Compute was ready to drop all the 8-bit machines. So to buy book. Anyway,
there was probably a ton of how to learn Teach Yourself Basic.
Yeah, but he and I both thought we had a way of doing it that wasn't going to be that hadn't been done right before.
Okay.
Approaching things in a more logical fashion. I always felt that all the basic Teach Yourself Basic books were done haphazardly. They didn't take the right steps. Well, anyway, never mind all that. So here's the fun part of my life. So I knew that my editor was going to be this person called Scott Card, and I was going to meet him at the West Coast Computer Fair in San Francisco. And so my wife and I went out to dinner with Richard and Scott Card. And I don't know how it came about, but somewhere in the course of the dinner, I mentioned that I really like science fiction. And Scott says, I write some science fiction. I said, really? Under what name? He says, under Orson Scott Card. I had never heard him called Orson Scott Card before. I'd only heard him called Orson Card. My jaw drops on the floor. I look at him and I say, excuse me, can we start this evening all over again? My name's Bill Wilkinson. What's yours? Anyway, when he finally wrote the novel, Ender's Game, he sent me one of 4 Xerox copies of the submission that he sent to his publisher.
Wow.
And it's got a wonderful dedication about how I taught him to basic and all that kind of stuff.
Wow. It's amazing. Do you still have it?
Oh, of course I do. You've got to be kidding me. I wouldn't give that up for anything.
Wow.
It came in just a box of a box that the paper had come in. What's the word I'm trying to think of? Like copy paper, a copy paper box. It came in a copy paper box, and several years later, my son finally took it out and put it all into a 3-ring binder using hundreds of plastic sleeves, so that we didn't have to touch paper.
Nice. All right, tell me more stories. You have stories. Tell me.
Oh. I don't know. That's probably the funnest one. Most fun one. Well, okay. the first real computing job I had was at Aerojet Electric Systems, and I was hired soon after I graduated from college, although I'd already been doing civil engineering work for 3.5 years before that. And I worked with a guy whose father was the one that designed Magic Mountain at Disneyland.
Okay.
Although that's kind of irrelevant to this topic. And I loved assembly language, and most of the other people there only programmed in Fortran. So, for example, I was given the job of rewriting IBM's library routines for the sine and cosine of a number into a function that did both sine and cosine and returned both of them. Because if you did that, you could save roughly a third of the time compared to doing them both separately.
Okay.
Just because of the way the algorithm worked. And, they were enormously pleased with the fact that somebody could figure out the assembly language in Atari, figure out IBM's assembly language first of all, and then how to do it. And so they hooked me up with this guy who had many more years experience than I did. And together we wrote basically an operating system, a real-time operating system for an Interdata 832 computer. And I would never have gotten a chance to do that if I hadn't shown that I could write assembly language, because, of course, it was all written in assembly language. Mm-hmm. And that's what got me started in assembly language. My next job then was working on that calculator I told you about with the 4-bit processor. Mm-hmm. And for that machine, I wrote most of the math routines. Sine, cosine, exponent, log, that kind of stuff. So that was my introduction to assembly language, and I loved it ever since, except I just haven't used it in, 17 years now since I actually did any serious assembly language. Who wants to write Pentium code?
Yeah, that's not as fun.
Anyway.
I think I have 2 more questions. I know you're trying to wrap it up.
Sure, let's do it. Go ahead.
Okay. First question is, what haven't I asked you that I should have?
What have I told you that I shouldn't have? Let's think. Well, what's happened to Paul and Kathy. Mm-hmm. And honestly, I don't even know what's happened to Mike. Other people that were involved, of the other people that were involved there, I've kept in touch with a couple of them, mm-hmm. although very sporadically, and I really need to get in touch with them again. There was Paul Courier, who worked there for quite a long time. Well, for quite a while. I won't say quite a long time. He came in at the end and mostly helped out on the Personal Pascal and the Prolog project. Mm-hmm. And I'm going to hate myself for this one because my mind just went blank. I shouldn't have said Paul's name first.
Mark Rose?
Oh, Mark Rose. Thank you. Thank you for saving me. I had his name before I said. I had his name before I said that. Okay. And Mark was definitely, I think, probably the brightest of all of us, excepting possibly for Kathy. He was a Stanford grad. Can you believe he came to work for us before he was working for us before he went to Stanford even. So.
All right, and then I think my last question is, if you could send a message to the Atari community, and you can, right? And you can right now, what would you tell them?
Tell you what, let me think on that one and send it to you via email. How's that?
Okay.
And,
all right.
And it's perfectly okay to bug me if I don't give you an answer within the next day or two. Okay.
Okay, I'll do it. Cool.
Okay. I don't want to come up with some dumb answer right now. I want to come up with a better one.
Okay.
Okay. All righty. Well, maybe we'll talk again soon, hopefully.
Great. I really appreciate your time. Thank you.
When you ask me more questions. All right. Talk to you. Bye-bye.
All right. Bye.
Bye.
Bill emailed me a couple of days later with a follow-up message answering my question about his message to the Atari community. Here's what he wrote. The reason I loved the Atari 8-bit machines was that they were so easy to completely understand. Consider that the source codes for the internal OS, DOS, and even BASIC were all available. And of course, the hardware schematics were all out in the open. As I mentioned to you, the one and only piece of hardware I ever designed was the Bank Select cartridge. It didn't, and I suppose it still doesn't, take a lifetime of study to grok how it all works together. Though I have moved on to more modern software, I have never been able to get a feel for the hardware and software interaction as I could with the Atari 8-bit. So if you still have a love for these little beasts, I completely understand. For me, there will always be a soft spot in my heart for them and for the many years I spent with them. Thanks to Bill for taking the time for the interview, and thanks to you for listening. Bye.